Hey everyone, this is Jacob from YOLOv4. Today I'm going to show you how to train YOLOv4 to detect your custom objects within Google Colab and within the Darknet framework. Training YOLOv4 is easy. The only thing we need to do is show the network the objects that we want it to detect. So in order to train YOLOv4 today, we're going to take a few simple steps. The first one is to gather our data set, organize it, and export it into our Colab Notebook. Once we have the data in our Colab Notebook, we will make and build Darknet. After we've made and built Darknet for training, we'll write a custom training configuration file. With a custom training configuration file, we'll be able to specify the size of the network specific to our dataset in order to train on our custom objects. Then we'll kick off training, and this may take a while, but then we'll eventually have our trained network. Once we have our trained network, we'll make inference on custom objects to show you that the network is working. And so before we dive in today, I want to show you a little bit about what YOLOv4 is. So YOLOv4 is a state-of-the-art object detector. Object detection is the task of taking an image and finding objects in it by locating it with bounding boxes. So now today, we'll be using YOLOv4, which is a state-of-the-art network. YOLOv4 is state-of-the-art in terms of its speed to accuracy ratio. So these networks have been trained to be as small and efficient as they possibly can, while achieving the highest accuracy that they possibly can. This chart here is a map of network performances on the COCO dataset. The COCO dataset is a large dataset containing multiple different kinds of objects for a detector to detect, and it's considered kind of the gold standard general task for these detectors to learn. Here in this graph, you can see that you have YOLOv4 up here in green, which is achieving a higher accuracy compared to other networks at a faster FPS, which means a faster inference time. The nice thing about faster inference time too means a smaller network which is quicker to train, which is easy for us to get started on training and figuring out how to tune our own custom networks based on this base network. So today I'll show you how to take the network that has been trained on the COCO dataset, which is just a general dataset, and to fine tune it into your own custom objects so you can train a network that can detect anything that you want to in the world just by using supervised training data via a labeled object detection dataset. So now, that's the next step, is to get your labeled object detection dataset. So in order to get started, I've gathered a dataset of raccoons, which I've labeled with bounding boxes around each raccoon, and today I'm going to show you how to load that dataset into YOLOv4 and to use YOLOv4 to create and manage your dataset versions before exporting the data into the Colab Notebook for training. So today, if you were to get started with this, you would just log into YOLOv4.com, and you would go ahead and create an account or sign in. I'm just going to sign in here. And in order to load your data in, you just go up here and you hit Create Dataset. I'm going to call this Raccoons YouTube. And I've already made one of those, so I'll make another one with an annotation group raccoons. The other thing here is to specify the dataset type, which is object detection. So here we go, we've created a new dataset, and here you can go ahead and drag and drop in whichever files you might have. We support pretty much every kind of annotation format at YOLOv4, so you'll be able to load in whatever format you have, whether it be Pascal VOC or YOLOv4 Darknet already, or COCO JSON, or whatever format you have, it will load in here. So we can go ahead and select our files. I'll go here to downloads where I have my data set, and I will load in this raccoons COCO dataset. So here we can see our data set is loading in, and you'll know if this is working if you can see the bounding boxes are drawn around your object. So here we can see a bounding box is drawn around each raccoon. Then we'll go ahead and finish upload here. And we're going to split our data set into 3 different sections of data. So the first one is training, which will show our model to teach it to detect our custom objects. Then we're going to show it our validation set, which is basically the network will check how it's doing against the validation set, but it won't actually be tuning using it. And then at the very end, we'll run inference on our test images, which is images that the network has never seen, not even to check its performance like it does in the validation set. So we'll go ahead and upload these images here, and here we're actually loading the images into the YOLOv4 cloud for future processing. And one thing to note is if you don't already have a labeled data set, I'll link some labeling tools below so you can get started with drawing bounding boxes around your objects after you've gathered your images. So now that we have our data set in here, we can go ahead and use RoboFlow to create robust data versions of our data, which means that we can actually augment our data set to be larger than it initially is. So there's two different things we can do here. We can make pre-processing steps, or we can make augmentation steps. Pre-processing steps are initial steps that are applied to all sections of your data, whether it be training or testing. And these basically standardize your data set in some way that makes it easier for the network to learn from, or some way that you suspect will make it easier for the network to learn and perform on. So today for pre-processing steps, we have a few auto-filled here. We're going to resize our images to 416 by 416. The resolution you're passing into the network is a very important thing to pay attention to. It specifies how large the image is coming in, and it will always help the network do better if you provide a larger image, but it will take longer time to train, and it will also take a longer time to inference. So you have to keep these things in mind as you're resizing your images. Then other things we can do is augmentation steps. This actually generates more data from our original training data, and so it means we can make a larger training set by augmenting, by doing some deterministic changes to our images. So it's an example of some of these changes that we can do to make new images from base images is to crop, or we can flip, or we can rotate. So today I'll do a few. I'll just do a little crop, which kind of simulates zooming in and out. And I'll do a blur here in case the camera is a little bit blurry. And another one we might want to do is, let's say, brightness. Maybe it's a little bit darker, brighter of a day to detect raccoons. So we can make this augmentation step as well. So there we go. We have a few different augmentation steps here, and we can choose how many images we want to generate from our base images. So here we go. We'll go ahead and hit 3 here, and we can generate and create a new dataset version. So this is all to get started on just getting our data organized and set up and in a place that we can export it into the Colab Notebook. Of course, if you already have this done, you can just jump ahead to the part where we actually start getting into the Colab Notebook and writing the code. So the format you want to choose here for export is YOLO Darknet. YOLO Darknet is going to be the dataset format that YOLOv4 is going to consume during training. So we need to make sure to specify the right dataset format to go into the network that we're heading into. So we can choose YOLO Darknet here, and we can go ahead and hit Show Download Code. So I'll go ahead and do that here with my data. And this will zip up the data and post it to a link where you can simply just correlate into the notebook. So here you go, here's your data link. It's important that you keep this private since it has some private keys. But I've already went ahead and loaded mine into the notebook, so we'll go ahead and just jump in there and dive into training. So here we go, switching over to the YOLOv4 Darknet Colab Notebook, written here for you and delivered by RoboFlow. I will go ahead and show you the steps to go ahead and train on your custom data. So the first thing is we need to make sure that the network can leverage the GPU that Google Colab provides for us for free. So the first thing you need to do to make sure that has happened is go over here to runtime, and you can go to change runtime type, and you can go ahead and put GPU there to make sure that you're actually leveraging the GPU resources available to you. So I've already gone ahead and done that, and to check and make sure that that's the case, you can go ahead and here and check your CUDA drivers, and also check NVIDIA SMI. So NVIDIA SMI will give you a quick peek into the GPU underneath Google Colab. So here we can see that I received a Tesla V100. So this is actually pretty rare. I have almost always received Tesla P100s from Google Colab, but today you have the pleasure of watching me train YOLOv4 on a Tesla V100. This is a real rare experience with Google Colab. So there are some variables you can set here based on the GPU you provide, but I've tried to make a makefile that's general enough that should be able to work on any GPU you receive from Google Colab. So the first step here is to cd into content and to remove the Darknet folder. We're going to go ahead and reclone that. I've already done this, but normally you would just be executing these sequentially. And then we're going to actually remove the makefile, and we're going to make our own makefile based on the one that I provided here in the notebook. The makefile basically specifies the commands needed that the computer needs to build the Darknet application on the base Colab configuration. So it changes based on GPU, based on CPU, based on if you have cuDNN, based on if you have a lot of things that hopefully you don't have to worry about because we've just kind of written it automatically in the notebook. And these are things you might get familiar with more if you just keep diving in deeper and deeper after this tutorial. But for now, you should be able to just run this next cell, which is to basically exclamation point make. So this makes the Darknet framework. So this is where it's actually building the C code application based on the specifications you made in the makefile. So here you're going to see a lot of strange C printouts, which I'm personally a Python guy, so I don't often build things in C, but every once in a while we'll find ourselves down there to build things like the Darknet framework. So I guess, while this is building, I could go on a little bit of a tangent of what the Darknet framework is. So it was originally written by this guy, P.J. Reedy, in his PhD to train custom object detectors and to basically beat the best object detection benchmarks on the COCO dataset in terms of performance to speed. And so now it's kind of still left over and being iterated on by new people here. This YOLOv4 version is published by Alexi B in the Darknet framework, where they're actually writing their own C code to make back propagations and stuff, which means you don't have a native framework like PyTorch or TensorFlow to do all the neural net calculations. But that's probably more than you ever wanted to hear about Darknet. So we'll go ahead and move along when this finishes building. So once that finishes building, the next thing we're going to do is we're going to download pre-trained weights. So these are weights that are pre-trained on the COCO dataset for YOLOv4 in the YOLOv4 format. And that means that the network's already been kind of tuned in to identify certain kinds of objects. So that means you can kind of start, you don't have to start completely from scratch on identifying what an object is. It already kind of has an innate sense, and then you can tune it in to understand the things that you want to be teaching it. So now this is where we would go ahead and download our data set. So I guess one thing is I'll go back to the data set and kind of show you a little bit what's in there. So these are all just pictures of raccoons. So this is where we're actually downloading in the individual image files with the annotation files attached. And the annotation file just defines the box where the object is located. And you can use RoboFlow to kind of get a good sense of what your training images might look like. So there we go. I've already downloaded my raccoon data set in here. And here we're just going to write some code to kind of basically tell Darknet where our data set is. So we need to make like files that basically say this file is here, this is the training set, this is the validation set. Again, things you can hopefully just abstract around since we've already written it for you. Okay, so now the next step is to write a custom training configuration file. So this is actually where we're going to specify the shape of the network based on our custom data set. The main thing here is to take the YOLOv4 config and then to tune that in based on your custom number of classes and for how long you want to train it for. So these are things that kind of will automatically write themselves in the file based on your data set coming in from RoboFlow. But if you want to dive in yourself, you can kind of look through here and see what we're doing. So basically we need to change the shape of some of the layers based on the number of classes, and we're going to tell it how many iterations we want to train it for. So Darknet talks in terms of iterations, not epochs. Iterations just the number of times that it's going through a batch. And you can also specify the batch size. So if you're getting a GPU out of memory error, you want to actually just shrink your batch size. And if you want it to go faster, try making your batch size a little bigger. But I should have presets in here for you so you can just kind of use what's here and it should work for you fine. So the next part is to, here we can go ahead and take a look at the file that we've written. So here you can see it's actually defining the network layers as we're going through here. This is the YOLO state-of-the-art network format. And yeah, again, for the most part, you can dive in there as much as you want or just kind of abstract over it and move on to the next step. So here we're going to actually kick off training. So we point to a few important things. We're going to point to our data /obj.data. This is where we have those data files, which basically have the the routes to our training data. And then we're going to also point to the config that we just wrote. This is the custom config based on the data. And the other thing we point to is the pre-trained weights to kick off from. And that's sort of the main 3 ingredients that are going to go through into training. And so now we'll go ahead and kick this off. As this is kicking off, you'll see a few things that'll print out your environment variables. So you want to check for things like CUDA, cuDNN, that the GPU is getting hit. So kind of check that top area to make sure everything is set up. And then you'll see the network actually build. And then it will start provisioning memory into your GPU, which will start loading your images into batches and starting to kick off training. So one nice thing that I've done here is I've actually removed a lot of the print statements from training, because the normal Darknet framework will just send you like a ton of prints about all the losses in all the different regions of the network. But here we'll just kind of send a few base metrics from training. The first one is the average loss, which you want to see the average loss kind of slowly start to decrease as training continues. And then every 1,000 epochs, or 1,000 iterations rather, it will print out an MAP calculation. So I'll also link below a little blog on what MAP is if you want to know a little bit more on that metric. But basically you want to see loss go down and MAP go up. And as you're running your experiments, you can try to optimize for those metrics. So now this is going to take quite a long time to train. So I'm actually going to take off for a little bit, and I'll go ahead and just fast forward this video. Okay, so training has completed. I stopped it a little bit early here, so we'll see how the test inferences look. But you can see here that our training has converged all the way down to through 1,000 iterations here, and we're already at 1.2 average loss, so the loss function has gone down a lot since the beginning. And we see here that we got a map of 84.5%. So that's a really great map. It was a pretty long training job, as yours will probably be as well, but that's a small price to pay for a custom tuned detector to detect your custom objects. So if you want training to go a little faster, there's a couple of options you could do. You could go ahead and check out our YOLOv4 Tiny How to Train YouTube video. So RoboFlow, How to Train, YOLOv4 Tiny. That's a little bit smaller network. We'll train a little bit faster and we'll infer a little bit faster. Another option is to check out RoboFlow, How to Train YOLOv5. That's in the PyTorch framework, and PyTorch is going to run a lot faster than the Darknet framework is going to run. So you can also consider going out and checking out those videos if you want a little bit faster training time. So now moving forward with the YOLOv4 tutorial, we've trained our network, and we're going to use our trained network to make test inference now. So here's a little utility function to display images. And then we're going to look at our backup directory. So the backup directory is where weights are going to save during training. So here you can see where weights have saved, and there should be a few different ones. It'll checkpoint every 1,000 iterations, and then it will checkpoint the last weights no matter when you stop training. And then it will also checkpoint the best weights. And the best weights are based on the map calculation, so it will kind of use your validation set to take a guess at where the best weights to pull from are. So if you get best weights, you definitely probably want to use those. So next we'll copy in our class names so we can use those for inference. And then this script here just does some inference where it calls your weights. So here I've got the last weights coded in, but I'm going to switch those for the best. And then here I have the script to just take a random image from your test data set and run it through, just so you can get an idea of how your detector is. So when you kick off training, it will rebuild the network. In deploy time, you can kind of have this already pre-built, so you can just be doing inference on the edge. There we go. There's a raccoon that didn't get detected. Makes sense. That was kind of a weird image. So let's try another one. So there you go. You can see here that our detector has learned how to detect raccoons. It's drawing a box around a raccoon that is in the test set, so it's an image that it has never seen before. So then lastly, another thing you can do is you can download these weights. So you can download them and then deploy them in other instances. So I had forgot to write this in there, but I'll write it live. So from Google Colab, import files, and then you can do files.download, and then to download you'll just go ahead and pick the location of the files that you want to download. So I'll go ahead and pick the best weights, and we'll do download here backup / these weights, and that will go ahead and download it down into your local file store, so you can put it up on the cloud wherever you want, deploy it to the next location, and then most importantly, you don't have to kick off training again. So once you have these weights from the Darknet framework, there's a few things you can do after that. So you can convert to OpenVINO, and then that's to deploy on NVIDIA or on Intel hardware. And then you can also convert to PyTorch. There are repos for that. If you go to PyTorch, then you can deploy on, say, like NVIDIA frameworks. And then you can also convert to TensorRT. There are repos out there for that. And all these things are available, just kind of like Google YOLOv4, Darknet 2, wherever you want to get. And since this network's been out there since May or so, a lot of these repos, conversion repos, have popped up, so you can take your trained weights and bring them out for deployment wherever you would like. So that's all for today for our video. Hope you enjoyed watching, and stay tuned, like and subscribe below for more future training videos and computer vision videos. And thanks again, and thanks for watching the RoboFlow YouTube channel. See ya.